G'day and welcome to the next video in the calculus series. This one we'll be looking at the quotient rule. I guess quotient is kind of a one function divided by another. This is exercise 5.9 in your textbook. So obtaining the derivative of one function divided by another one requires the quotient rule. So for example, if you had x divided by sine x, we can actually get the derivative of this function by using the quotient rule, and I guess I'll show you some examples a little bit later. Okay, so again, there's a couple of different ways that you can go about this. The final one is the way that I learnt it, but I'll show you the other couple of ways too, because I think they are helpful. Imagine if you've got h of x equals f of x over g of x, like I had before, x and sine x. The rule for the quotient rule is actually this. It's g of x multiplied by f dash x minus f of x multiplied by g dash x all over g of x squared. Okay, or another way of doing that is if you've got u and v are just functions of x. So the rule for this would be v multiplied by du dx minus u multiplied by dv dx all over v squared. Okay, I guess the final one that I want to show you, or the way that I remembered it, is using words. And so I would say the quotient rule is this: it's the bottom, so g of x in this case, multiplied by the diff of the top, so f dash x, minus the top f of x multiplied by the diff of the bottom, g dash x, over the bottom squared. Okay, so the bottom times the diff of the top minus the top times the diff of the bottom over the bottom squared. Again, it really doesn't matter which way you learn it or how you apply it, as long as you're able to. Sometimes when the questions get really tricky, like the next video I'll show you, I've just got an absolutely ridiculous question. This one in your head doesn't work so well. It's still true, but it's just harder to hold all of the information, because often you use the chain rule inside the... You possibly could even use the chain rule and the product rule inside the quotient rule, and it just gets really ugly. So it's good to know kind of all three of these ways. I'm going to have a look at this one here, and I mentioned this in a couple of videos back. Those of you who are watching an alert will notice that sine x over cos x is actually tan x, and when we did the derivative of tan x, I told you basically. Just clear that up a little bit. Y equals tan x. I don't know if that's any clearer, but still, I told you that dy dx is actually sec squared x, or dy dx in this case was 1 over cos squared x. Okay, I'm going to prove that to you right now. So I'm going to use the quotient rule. So I'm going to say that u equals sine x and v equals cos x, and I get du dx and dv dx. It's very helpful to write all of these things down, because then you can just put them in the formula. So the derivative of sine x is just cos x, the derivative of cos x is negative sine x from exercise 5.7. Okay, and then I get, I use the product rule, sorry, the quotient rule. And so it's the bottom, which is cos x, sorry, multiplied by the diff of the top, which is cos x, minus the top sine x multiplied by the diff of the bottom, which is negative sine x, all over the bottom squared, which is cos x squared. So I end up getting cos x squared plus I should say cos squared x rather than cos x squared, because people get confused. So cos squared x plus sine squared x all over cos of x all squared. Now, those of you who are awake and alert will know that cos squared x plus sine squared x is always equal to 1. So I get 1 over cos squared x, which also equals sec squared x. So the derivative of tan x is true. We already knew this, but now you know why the rule works. That the derivative of tan x is actually 1 over cos squared x, or sec squared x. Okay, so that's all I'll do for this video, because in the next video I want to show you an example where things just get really, really crazy. So if you want to start on exercise 5.9, you can, that's fine, and then come and have a look at this crazy question a little bit later. So thanks for watching.